The necessary and sufficient conditions for phonation would be the arytenoids are pulled together so the vocal folds are in the paramedian position. Then you would need medial compression of the vocal folds, which creates longitudinal tension. And in order to sustain the longitudinal tension, you need enough subglottic pressure that's built up underneath the vocal folds so that in order for them to be blown apart, so in order for them to be abducted. And the production of subglottal pressure is essential for respiration. The respiration component during exhalation would be the elastic recoil, which forces the lungs to cause a decrease of volume in your thoracic cavity, which drives up the pressure, and that's how we generate our pressure. Muscles of exhalation and elastic recoil forces in the thoracic cavity and the diaphragm to return it back to its original resting position and decrease the volume of the cavity and increase the pressure, which then will establish the phonatory threshold. Now I will explain the function of each intrinsic muscle. So the posterior cricoarytenoid is the abductor, which are these parts right here, and it's going to, the vocal folds are going to open, which is where we, when we have a glottis and we're breathing. Then we have the transverse arytenoids and the oblique arytenoids, which are our inner arytenoids, and I already pointed them out. The oblique looks like the X, and then the ones that are orange are going to be the transverse arytenoids. The cricothyroid, which controls our pitch and is our tensor, it's going to be right alongside right through here. And the lateral cricothyroid was the white, and it's also an adductor. So the only abductor we have is the posterior cricoarytenoid. And now the cartilages. I will explain them and how they relate to each other and the effect that they have on the vocal folds. The cartilages move, and the inner arytenoids and the lateral cricoarytenoids pull forward and down on the muscle process, which rotates the vocal process inward. The cricothyroid causes the thyroid cartilage to rock forward, increasing the distance between the anterior and posterior attachment of the vocal folds. And while the vagus nerve supplies pretty much everything laryngeal, all intrinsic muscles except for the cricothyroid, the nerve supply comes from the recurrent laryngeal nerve. But the cricothyroid is supplied by the superior laryngeal nerve. And now I will explain the myoelastic aerodynamic theory of phonation. This theory basically states that in order for phonation to achieve, you have to have your vocal folds have to adduct, medial compression, longitudinal tension, subglottic pressure has to be reached, and your phonatory threshold has to be reached. Phonation begins when the phonatory threshold causes the vocal folds to open, which abduct, and air rushes through the glottal space. When that happens, the Bernoulli effect comes in, and the vocal folds, this causes an increase of velocity of airflow through the glottis when there's a decrease in pressure along the constriction of the vocal folds. When there's a drop in pressure against the vocal folds, when there's a drop in pressure along the sides of the vocal folds, there is a decrease in pressure overall, and then the vocal folds are held open longer, and then they suck back together, so they adduct. And the subglottic pressure will build back up again and blow them apart, and pressure will drop, and so on. It would continue forever. But it goes 100 or so times per second. And the mucosal wave, all I have to say about that is that it's just the moving pattern of the vocal folds during phonation. And it goes from inferiorly, the bottom, to superiorly, the top. That's a wrap. Thanks.